My name is Anuar bin Mohamed, EA18122, the programmer in this project. So, first thing first, we need to declare the library of servo for motors and the liquid crystal I2C.H for the LCD 16 by 2. Next, we need to declare the servo 1 and 2, which is for the roofs, and servo 3 is for the door. And the integer LDR value is for the LDR sensor. And in this project we use three functions to be executed in the void loop, which are myPIR, myRain and myLDR. So let's begin with the void setup. We will use the baud rate of 1900 and we have three inputs, the LDR and the rain sensor and the PIR sensor. So the output will be the LED for the light bulbs in the garden. So first thing first, we need to attach the servo to the pin 6, 5 and 3, and like as usual we need to use the LCD I2C. We need to declare the LCD init and LCD backlight for the starting up the LCD, and after that we need to display the weather on the LCD. Okay, let's move to the void loop. This is our void loop. It consists of the myLDR, myRain and myPIR functions. So starting with LDR, we use the analog rate, which is 10 bit, 0 up to 1023. So if the analog value is below than 700, it means the day is turning up to night, is moving to night. It means the LED need to be high in this case. So as you can see, if else, that means the analog value of LDR sensor is 701 upwards, it will be low. That means the condition is the day. So let's move to myRain. We want to use the analog rate actually for the integer rain, since our hardware can only detect 2 cases in this switch case. So we decide to use the digital rate since it has 2 cases also, which is high and low. If the rain is high, it means if there is rain on the sensor, that means the LCD will print Hudan and the second row will display roof open, and the motor or the roof will open up to 120 degree. And if there is no rain, the motor will remain or will close to 0 degree, and the LCD will print normal, and the second row will display roof closed. So for the myPIR has no analog rate, so we use the digital rate for this sensor. And if there is if the PIR value equals to high, or is there if there is a motion around it, the door will be open up to 120 degrees, and the serial print will display motion detected, and the delay will be applied so that the man will not be hit by the door instantly. So the delay is important here. You can change it up to 5,000 or 3,000 milliseconds, and if there is no motion or PR value equals to low, so the door will not be open and the motor will remain to 0 degrees. So the motion is the delay will still be applied. So thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Norsyuhada Maisara Binti Sobri. Matric ID EC18066 from University Malaysia Pahang. I'm going to present the next part, which is the Proteus circuit of our project, Smart Garden. Alright, as you can see, there are 3 types of sensors used in this project, which are rain sensor, light dependent resistance sensor, and also passive infrared sensor. The power system of this project is the power supply and battery. Arduino Uno R3 microcontroller will be the one that controls the overall system to deliver the output of this project, which is servo motor and light emitting diode. First thing first, using Arduino coding from the previous presenter, we search for the hex file. Copy the hex file and paste it into the Proteus software. Click OK. Then we can run the simulation. When we run the simulation, the LCD will display "Hello there" and getting started. Then the LCD will display weather normal. We are going to test the first sensor, which is the rain sensor. As you can see in the LCD, it displays normal, but when we set the test pin equal to 1, meaning that it is raining at that time, the LCD will display weather hujan and roof open. Both of the motor connected to both sides of the smart garden roof will turn, meaning that the roof is open, giving access for rainwater to be consumed by the plant in the smart garden. The next sensor we are going to test is the passive infrared sensor that is connected to the motor of the door of the smart garden. When we set 1, meaning that there is a movement within the range of the PIR sensor, the motor will turn, making the door open to give access for the user to enter the smart garden. And when we set 0, there is no movement, the motor will turn as well and close the door of the smart garden. The last sensor we are going to test is the light dependent resistance sensor. As you can see, when we put the light closer to the LDR sensor, the LED bulb will turn off, meaning that there will be no LED turn on during the morning. However, the LED bulb turns on when the light is away from the LDR sensor, which means there is no light during that time and it is during the night. That's all from me. Thank you. Assalamualaikum.
Hello, my name is Asyraf bin Abdul Aziz with ID number EC18090. I will be presenting the hardware part of Smart Garden. In this section, we have made an automatic door for user to come in without use their energy to open the door. The PIR sensor were used to detect a movement of a person. During the day-night, LED will light up to provide enough lighting to help plant to grow. We use LDR sensor to differentiate the daylight and the day-night. We use this lamp to indicate during the daylight by placing the lamp near the LDR. And the LED will light off. We designed an open roof system which will make this smart garden look more attractive and innovative. We implement a rain sensor to detect during raining, and from the rainwater as an input, the roof motor will open the roof to give rainwater to plant. When there is not raining, the roof will close.